Hello everyone, thank you so much for staying to hear my presentation. My name is Daniela Blanco. I am a PhD student in chemical engineering at NYU, and I'm also the co-founder of Synthetics. And I'm standing here today because if you look around you, in 2018, pretty much everything you see is made by the chemical industry. Now the problem is that the chemical industry has also become the third largest contributor to greenhouse gas emissions. And why hasn't this changed? This industry has lots of traditional and expensive infrastructure with very little motivation for change. And sustainable change? With the reputation of being more expensive, it usually loses priority. But I dedicated my research and effort to co-found Synthetics, a company that finally changes this paradigm for a massive chemical product, because I understood that for sustainability to be implemented, we needed to offer something else. And that is why I developed a process to produce the key component of nylon in a way that is more efficient, less expensive, safer, and for the first time, it can also be sustainable. But how did I get there? Well, let me introduce you to the 3-year-old me. I was born in tropical Venezuela, located at the north of Latin America. Only daughter to this beautiful lady, my mom. She's a single mom and the most loving and strongest woman that I know. It has always been the two of us for as long as I can remember, and she has always been the biggest supporter of my dreams. I think I was 4 years old the first time I told her that I wanted to do science, but the good kind of science, the kind of science that helped people. And even as a single mother who was suffering harsh discrimination as a female engineer in a male-dominated field, she was ready to sacrifice everything for this dream of mine. She wanted to enroll me in one of the biggest high schools in Venezuela, and we couldn't afford it. But as I argued that, she only replied she didn't think it was a good excuse for us to quit on my dream. And if she was ready to do everything on her power, then I was ready to do everything on my side. I graduated top of my class with a scholarship on this high school, and I then got accepted into the best engineering school in Venezuela, Universidad Simón Bolívar. I fell in love with chemistry, to the point that I was head of the Venezuelan delegation at the International Chemistry Olympiads, and I also got a scholarship to study in France for a year. When I was there, I did my internship at the R&D department of one of the biggest oil companies. And that's when it hit me. I didn't want to be just an engineer. I loved research because I loved innovation. But it didn't matter how much I wanted to innovate. My impact was going to be limited because Venezuela hit bottom. Communism stole our freedom and stability. Protests became our day-to-day life, as our nation united in the search for democracy and peace. But all we encountered was a merciless government that was willing to kill, imprison and torture civilians just like you or me, who had no weapons to defend themselves. And it is hard to imagine the desperation one feels when this is what happens to students my age, my friends and my classmates, as we fought together for our right to think and to live in democracy. Knowing that I was left in a country that had no medicines, no food and no safety, I realized we didn't have a future. And with my heart in a million pieces, I knew that I had to leave. But that's how I found NYU. And I got accepted into their PhD program in chemical engineering. As I started, people told me that the hardest part would be to succeed as a woman, as Latina, with a language barrier, without economic resources from my family. Some even thought that the hardest part would be the knowledge that I was initially lacking. Because when I first entered the lab, I didn't even know what any instrument around me was. I had never seen them before. However, no one was right. Nobody realized that the hardest part would be for me to be here with my heart and mind in Venezuela. Because as much as I value and enjoy the opportunity to be here, it is incredibly hard to leave worried for my family and friends who are still trapped over there. However, I couldn't give up. I worked hard and I now get to use my PhD to fulfill my dream. I get to innovate with purpose. And you guys already know the problem that I wanted to solve. As I mentioned before, the chemical industry is the third largest contributor to greenhouse gas emissions. But I was formed a chemical engineer precisely to challenge the status quo of this industry, to reinvent the chemical industry as we know it. It is right now such a large contributor to greenhouse gas emissions because this industry uses heat to power chemical reactions. And the heat comes from burning large amounts of fossil fuels, which release CO2. But I have a dream in this new generation of chemical engineers to electrify the chemical industry. That means using electricity instead of heat to power chemical reactions, making these processes more efficient, safer, and renewable. These electrical reactions can be implemented in a variety of sectors, but I decided to start by looking into one of the largest processes, nylon. Nylon is everywhere, on the chairs that you're sitting on, all the way from textiles to engineering plastics or even car parts. It holds a $35 billion market, and it is produced in a 3-step chemical process. Now, the demand for nylon is increasing so rapidly that it's causing huge shortages in the market. Specifically, the first step to make a chemical called ADN is the bottleneck. Companies that make this chemical are currently running into 3 main challenges. Their current process is expensive, inefficient, and unsustainable, making their capacity increase costly and very dangerous. But that is exactly where synthetics comes in. As a supplier of the first chemical used in electricity, we offer our customers, the nylon manufacturers, a 30% decrease in price, a higher efficiency, as our technology uses 50% less raw material and energy, and we produce half the waste. And finally, I designed a reactor that inputs DC electricity instead of AC, which allows us to diversify our energy sources in a cost-efficient way, even if we tap into renewables. That means that we get to use the energy source that we want. And if we decide, for example, to use solar energy, we can offer the very same cost advantage while also being an emission-free process. If implemented correctly, this technology can avoid the emission of 2.4 million tons of CO2. But to put that in perspective, this is the same as if everyone in New York stopped driving their cars for the next 6 months. That is how synthetics enters the market, offering safety, efficiency, cost, sustainability, and scalability. If we compare ourselves to the leaders in the market, we match their best performance indicators while also being sustainable and safer. For those using a similar route, we have higher efficiency and lower cost. And for those sustainable initiatives that are already trying to enter the market, we have major advantages in terms of cost and scalability. This is what our lab-scale reactor looks like. It's patented, it's about the size of my hand, and I developed this entire technology in the lab. But as you might imagine, that's not all I had to do. I developed the technology and continued the R&D for this process as part of my PhD at NYU. But now with my knowledge on this reaction, I am leading the scale-up, supported by PowerBridge, and also while we apply to Cyclotron Road, NSF, and other scale-up partners. Finally, I call it the business development of the company. And I don't have an academic background in business, but I continue to learn as much as I can from every competition and program that I join. And I also rely on an incredible board of advisors, specifically on the fields of nylon and electrochemical manufacturing. But what makes me truly proud, and I think is unique about being a hard tech researcher and entrepreneur, is the fact that I get to do all 3 of this. I don't just develop a cool technology as part of my PhD, but I make sure it becomes something big by building a business out of it. I use my customer interviews and the partnerships that I make to learn more about what is needed on the solution. And that is how the business development is shaping my research. Because I use my customer discovery and customer validation to adapt and build a better product. In the past year since we started, we have been able to pinpoint 5 potential partners, 2 letters of intent, and we have raised over $160K from competitions and grants, including the first prize at the 2 most prestigious startup competitions at NYU, and also most recently the first prize of the Green Tech track at the University Startup World Cup. Now, as I told you, we have a lab scale prototype, so our clear next step was that we needed to scale up. We have built and we're right now working on a reactor that is about the size of a football, and we will continue to grow to reactors the size of a suitcase. With this, we'll be able to reach capacities of 1,000 tons per year with a pilot plant. And last summer, we actually visited one of our potential locations for this pilot plant, Panama. Over there, we were able to set grounds for a potential partnership with Solar Istmo, the biggest solar farm in Panama, and also potential funding opportunities with Senacid and UN Environment Panama. Our goal is to have this pilot plant running by 2020, producing the very first cost-competitive solar-powered nylon chemicals, which will be used by companies such as Lululemon and Swedish Stockings, from whom we have letters of intent, to produce the very first nylon solar-powered yoga pants and nylon stockings. After this, once our technology is proved at scale, we'll be able to either license it or continue to grow in capacity by partnering with the strategic companies. All of this is, of course, made possible by an amazing interdisciplinary team. We have Professor Miguel Modestino, faculty at NYU, on our tech advisor. We have Ben and Kyle, who support us with their background in finance. And there is Miriam, my amazing colleague in business development and co-founder of this company. Now, as you might imagine, I don't want to stop here. I'm starting with nylon. but I'm already envisioning potential ways for us to, for example, develop clean and efficient processes to produce propiolic acid, which seems to be largely used for food preservation and in the stability of several cosmetic products.
2 minutes remaining.
And after this, we will continue to grow. Because my dream is that I will get to use my skills and my knowledge to transform not only this one, to get not only solar nylon for everyone, but to transform all of these different chemical sectors. I want and I dream that synthetics will be my platform to make the chemical industry clean, one reaction at a time. And that, of course, is no easy task. But I have a loving family that supports me in the distance and a mom who always gives me the strength to aim higher. Thank you so much for your kind attention.
Okay, judges, your 10 minutes for Q&A begins now.
Well, I don't know about you guys, but I feel pretty good about our future. That's to everyone else, by the way. This entire room, please. That was fabulous. Is there anything that can get in your way?
Yes, of course, but we're trying to stay ahead of that. For example, right now we're working on the scale-up of the technology. And even if I'm proud to be a female engineer and entrepreneur, you can't imagine how heavy the metal is to carry and how hard it is to drill it on my own. So there are a lot of challenges that we're going through, but we're definitely advised by very smart people, and we want to see this happen. So we believe in it, and I think that we're going to do everything that is in our power to make sure that it does happen.
So how do you balance your love for science with your love now for building a business and being an entrepreneur? And which is your true passion, and how does that go into the future?
I balance it exactly by doing what I'm doing right now, knowing that I get to do what passionates me, which is, make sure that this becomes something huge. But I do it as I also adapt my research. I know that it sounds kind of weird for some people, but it's truly encouraging for me every time I talk to a new customer and I realize that they want something different. And then I go back to the lab to try to make it happen. And that's how I do research, but I do research with purpose. I don't do the kind of research that maybe something happens by accident at some point, but I'm not just counting on accidents. I know where I want to get. And then I know where I want to get because I have this business passion, and I know what people, what industry, and what our planet, what our people needs. So according to that, I adapt my research.
I'd imagine there'd be some big competitors out there who would love to sort of get your product out of the way. What happens if someone comes and buys you, puts a big offer in front of you? Would you take it?
Right now we wouldn't, because we want to make sure the market is dominated by two main companies. They're huge companies, and in the past, when people have tried to get into this business, they have found a way to just get them out and have control over the entire price and the entire industry. So we do not want to be one of those companies that they just buy and that technology never sees the light of the sun. So right now we wouldn't accept anyone to be buying us. We would accept partnerships, we would accept help, we would accept co-development to make sure that this grows to the scale that it needs to grow, and to make sure that we do it on time to fill the market need and the shortage. But right now we are not open to sale. At some point later, when we actually see that we're strong enough to convince them that this is the way the chemical industry should go, then we have done our job, and then we can let them have it, let them continue to grow with it, and we will move into something else.
And do you have capital raising plans?
Yes, so right now we are actually not looking for any venture capital, because we do have many funding opportunities in the US. We have, for example, NSF that will give us up to $2 million to do this research. We have Cyclotron Road that is also for $200K. We're doing right now PowerBridge for $150K. So we have a potential of over $3 million. And for our first pilot plan, the one that will help us start to prove the technology, we only need $360K. We already have half of that. And for the next pilot plant, we need $5 million. So at that point, we might need to start looking into a seed round. But this first, on the next 2 years, we're not envisioning the need for venture capital. We're going to keep going for grants and competitions.
When you were talking about the pollution from the way it's currently done, you mentioned 26 million tons. Is that global nylon production?
Yes.
Is that, tell us more about any other environmental impacts that you may be able to impact.
Yes, so those 26 million tons of CO2 that nylon production releases, it's on the entire way, and it also considers the raw material. And also when it's not reused, and then on the way that we use it, it also counts the contamination from distribution of nylon to different stores. It counts everything inside. Nylon is actually considered one of the most polluting fabrics, the second one to be specific in most of the indices that people publish. What is interesting is that we have found that most of the people that are trying to change the production process, they think that the pollution comes mostly from the raw material. And that's why you have probably heard about bio-based nylon and bio-based materials. But this is where we have to actually think clearly. If you make the calculations, only 1/3 of the production, pollution, comes from the raw material, and 2/3 comes from the energy, which is why that's what we're trying to change. The energy is 2/3 of the entire production pollution that they have, and that's what allowed us to work on that.
How would you describe, as you look at the landscape of your life, many, many years to come, what do you think that you're going to leave behind for this world? What do you think that you're going to teach us?
I hope that I'll leave a chemical industry that feels different to the way that it feels to me now. I am so grateful to all chemical engineers, who came before me and have allowed us to have all these great luxuries and things that we have around us. They have made our lives great. But I also feel like I inherited a chemical industry that is highly polluting, and it's like this big monster that is so hard to move because they're so used to the way they're doing it. So I hope that even if in some years I haven't been able to change the entire chemical industry, I hope that at least people know that there is a way to change it. That if we work towards the right things, we can actually still have the life that we want, but we can do it the right way. So I hope that I will get the chemical industry to wake up. I hope that the next chemical engineers will know that renewable energies is a field that has a future. If we think about it right, and if we know where we're going, if we know the numbers that we need to get the economy of scale, if we know all of that, we can make it happen. So that's the chemical industry that I dream, not just for me, but for other chemical engineers and for all of us to be able to enjoy this planet for much longer.
Well, as a fellow nerdy engineer, I get you, so thank you for being with me. I know in my journey, I started as an engineer and then morphed into an entrepreneur. Where do you see yourself in that, or do you want to have that journey also? Do you see yourself forgetting to be an engineer and being an entrepreneur at some point?
I don't think so. Of course, things might change, but so far I really enjoy being able to put the two together. I know that, for example, even if the part of this complicated chemical reactions don't really work at some point, I also want to work on clean water for third world countries. In Venezuela, of course, we don't have clean water. My mom gets water at our house only 2 days a week, and hospitals do not have clean water. And I know that many other countries deal with this. So I would definitely I haven't worked on this yet because I don't have the time, but I would love to see if we can design devices that are portable and that allow us to clean water, at least to the point where they can run operations and run hospitals with this and not let people get infected by water that hasn't been fully cleaned. And I know that electrochemistry, my field on the PhD, can be used for this thing. It's not exactly what I'm doing now because it's not an organic reaction, but I do think that all of my dreams so far, I want to implement my engineering knowledge on it.
2 minutes remaining.
If you had the resources to hire 2 more people, what would be the roles that you would fill?
Right now, we would definitely hire someone in finance, because as we do not have their background, we have been working on our projections and doing the numbers as best as we can, but we would definitely be glad to have someone over there. And then the second one is one that we are actually we have it written down with PowerBridge that if we get the money, we're going to hire someone to help me with the scale-up. Because we're building several reactors and we're studying different things at the same time. So if I'm able to have someone else help me on this, we can move much faster. Yes, sir.
Your thirst for knowledge is inspiring, and it's one of our core values. I was wondering if you could have any mentor in the world, who would it be?
That's a very difficult question.
1 minute remaining.
There's so
Sorry.
many amazing people that it's impossible to pick one. But I can tell you the characteristics of the mentor that I would like. I want a mentor that always lets me know that there is no limit and that I need to find the right things. I need to know where the obstacles are coming, but that will not keep me down. A mentor that will trust me and that will help me get there. That doesn't matter how many times I've had and how hard the struggle is. That struggle is not going to break me. It's going to make me a better entrepreneur. I want that kind of feeling from my mentor. Thank you.
30 seconds. Go for it, Dee.
Oh.
What have you learned from this weekend?
I'm sorry?
What have you learned from this experience with GSEA?
That the US is not only making me an entrepreneur, but that it actually has so many brilliant minds and so many people working in incredible things that I feel so incredibly fortunate to be part of this community right now and to know that I don't know how many of us are going to make it, but we're all in a battle that makes it worth it.
Thank you.